So I know there were a number of kids that were frustrated about about solving this, but strangely enough, I think this one was actually easier than some of the ones we've done. Okay, that was the front. I should have never said that because I think Atulia was ready to string me up because she was like, "It is not that easy." I'm like, "Oh, it's just so easy. It's so okay." So Atulia can be a little intense. All right, conventional current. You should always start with conventional current because then you're applying the same rule to both batteries, okay? Now, a possibility would be that at this junction, the current goes this way, correct? Mm-hmm. Another possibility would be it would go at this junction this way. So we don't really know the direction in the middle. But yeah, but it makes sense that in the big loop, these batteries are actually working together, right? We just really don't know what happens in the middle.
Magic.
Okay? So, if you look at the big loop, and remember that the goal here is to try to find a loop that only has like one resistor or one voltage drop spot. So you can identify that and then look at the other loops, okay? So what's the voltage provided in the big loop? Yeah, 15 in this particular case, correct. 18 in the other version, I think. No, it wasn't 18, it was... Yeah, okay. So for just the big loop, we're going to ignore this. We have 9 and 6 working together in the same direction. Everybody agree? Yeah. Okay. So that's 15 volts, and where does that 15 volts have to be dropped? In the big loop. Yeah, the big, we're ignoring this. So this is the only place where you drop that voltage. So that's 15 volts. Yeah. So if you could do this step, then you're done. Right? Yeah. So I think that was what was confusing is in this case the batteries are helping each other. So what's the current in that spot if I have 15? Yeah, 15 amps. Okay. Now obviously this is different. That's a different wire. This is the same wire, so this is also 15 amps right here. Okay. Now let's pick another loop. The 9-volt side? Okay, so if we go this way, ignore this, then how many volts have to be dropped here? 9 volts, good. See, it is quite a bit easier when you do that first step. If that's the case, then how many amps are running through this? 3 amps. Okay, and if we assume that this is the correct loop, then it's going in this same direction. Now, if these two come together at this junction, what's the current right here? 18 amps. And then 18 amps here, and then it splits to 15 and 3. Yes, indeed, it is that simple. Your check would be this loop, right? Because that's the only loop we have not analyzed. We've assigned everything, so your check is this side. Does that loop follow the loop rule?
Yeah.
Okay, so you have negative volts if you go this way, correct? Does that make sense? So, okay, if I go through this loop, I have 6 volts available right here, correct? And I'm dropping 15, how do I do that?
Negative.
Yeah, you have to have like a negative voltage here. So really what you're doing is 6 minus a negative 9. Does that make sense? Mathematically, that's the way it works. Gives you the 15. Because this is backwards current if we follow this loop, right? So that means that's a negative voltage drop. Yeah. In reality, what happens is that this resistor is powered by this, right? So in reality, the 6-volt battery isn't really doing anything here. Does that make sense? So you've got current flowing here. The 9-volt battery is what powers that resistor, that appliance. And then you have these 2 batteries working together to power this appliance. Okay? All right, so that was the double battery. Not very many of you got that.